Statistics, here we go with section 1.8, summarizing quantitative data. So we're going to put it all together here. We got box plots and outliers, a couple of new pieces of information. This is going to be very formula-like today. So we're going to give you formulas, you're going to put numbers in and make some decisions. Since quantitative data is data that we can crunch numbers with, we should have a numerical way to decide if there are any outliers. All right, rules for outliers go like this. A low data value in numerical order is an outlier if it's smaller than this. Q1 minus 1.5 times the IQR. So we go find Q1 and Q3 and subtract them to find our IQR. That's the range of the middle 50% of the data. You multiply 1.5, you make it even bigger, and then you subtract it from Q1, you create a boundary number. If anything is less than that boundary number, we call it an outlier. A high data value is an outlier if it's larger than Q3 plus 1.5 times the IQR. So we take the IQR, which is the range of the middle 50% of the data, multiply by 1.5, making it bigger, and we add it to Q3, making a bigger number. If anything's larger than that, it's an outlier. So here's a data set. 1, 1, 2, 3, 4, 7, 8, 8, 10, 14, 37. Okay, there is a data set. Here's what we're going to do. We're going to find Q1, Q3, and the median. Okay, we should probably find the median first. So let's see, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. N equals 11. So that means there are going to be 5 little numbers and 5 big numbers. So I'm going to go ahead and circle 1, 2, 3, 4, 5 little numbers. And it's an odd number of data values, so there will be a middle number, and the middle number is 7. The median is definitely that 7 right there, so I'll put a little arrow with a median over it. Okay, that means that Q1 is going to be the middle of the lower half of the data. Well, there's 1, 2, 3, 4, 5, so there will be a middle number there, and Q1 is equal to 2. And then there will be a middle number of the upper half of the data, and so 10 is going to be Q3. We have a Q3 that's equal to 10. So what does that mean for us? We have to find the IQR. The IQR for this data set is IQR equals Q3 minus Q1. 10 minus 2 is 8. The IQR is definitely 8. Okay, this is where I'm going to find out if things are outliers. So I'm going to put a little brackety thing around 3 and 4, and I'm going to say outliers with a question mark out on the side. This is how I decide if we have outliers. We find Q1 minus 1.5 times the IQR. It's the same formula every time. So here we go. Q1 is 2. It'll be minus 1.5 times the IQR we decided is 8. Okay, 1.5 times 8. If you need a calculator, I'm going to turn a calculator on, and I'm going to get rid of box plots that I've seen with my AP Stats class. I go 2 minus 1.5 times 8. Well, when you multiply 8 times 1.5, you make it bigger. So that's going to be 12. 2 minus 12 is negative 10. So what I mean by this is anything less than negative 10 is an outlier. Do you see any data values less than negative 10? There are, oh wait, I'm not done yet, sorry. That's, yeah, 2, that's 2 minus, I get it. I'm sorry, I got lost for a second there. There are no low outliers. Had to double check my work, sorry about that. So, since there's nothing less than negative 10, we don't have any low outliers. Now let's find Q3 plus 1.5 times the IQR. Okay, so I go find Q3, it's 10. 10 plus 1.5 times 8 is going to be 10 plus 12. That ends up being 22. Do we have any data values that are bigger than 22? We do, that one right there. So, are there any outliers? Yes. 22, not 22. I'm a mess today. This number right here, 37, is a high outlier. There are no low outliers because we don't have anything less than -10. There is a high outlier because we do have something bigger than 22. Next page.